Okay, guys, we're going to learn about something new today. This is going to be a big topic going forward in chemistry. This is called Lewis structures, and they're so essential to chemistry and understanding the chemistry of what's happening for the rest of the year. And so I hope that you pay attention during this section. I hope that you have your guided notes out, Chapter 5 guided notes, and you're following along, and a periodic table. Because this is going to be something that's very important. Okay, here we go. So what are Lewis structures? You're supposed to write in your guided notes something here. It says, Lewis structures show how valence electrons are arranged in a molecule. So we talked about how valence electrons are arranged in an atom, in one element. We did dot structures, right? But now we're going to put those dot structures together and make a molecule. Okay, multiple elements or multiple atoms. Lewis structures are like putting electron dot structures together for each element in the molecule. So we reviewed electron dot structures last chapter, but now we're going to put them together, a whole bunch of them for different elements, and make a molecule. Remember that each element wants to have an octet of electrons. How many is an octet? 8. Please make that note. An octet is 8 electrons in its highest energy level, or they're called valence electrons. But what about hydrogen and helium? How many do they want? 2. Please make that note. Their octet would be 2. Their highest energy level, they want 2 electrons in it. Everyone else, though, they want 8. Remember when we drew electron dot structures, the electrons were represented by a dot. The valence electrons were represented by a dot. And we talked about covalent bonds in the last video. Covalent bonds, where there's these electrons that are shared between two different atoms, covalent bonds are going to be represented by a single line. So these two shared electrons, if they're between two different atoms, we're going to draw a single line, which represents 2 electrons. Anyway, we'll get to it in a second, and I'll show you what I mean by that. Okay, before we start with Lewis structures, there's this rule that's very useful when learning Lewis structures. It's called the HONK. A lot of chemistry textbooks just call it the HONK Rule, but I like to refer to it as the HONK 1, 2, 3, 4 rule. And I'll tell you why here in a second. The H in HONK means hydrogen or halogens, but hydrogen likes to form one covalent bond. So when you say HONK 1, 2, 3, 4, the H, hydrogen, likes to form one covalent bond with other elements. Oxygen. Now when we see oxygen with Lewis structures, oxygen likes to form how many bonds? 2 covalent bonds. Nitrogen, the N in HONK is for the nitrogen. And how many bonds does it like to form? 3. So nitrogen likes to form 3 covalent bonds. And the C in HONK is for carbon, and it likes to form 4 covalent bonds in Lewis structures. So I'm going to refer to this as we go through the video, the HONK 1, 2, 3, 4 rule. But before I continue, guys, help me out. What does the H stand for? Hydrogen. How many bonds does it like to form? 1. The O? Oxygen. How many bonds? 2. The N? Nitrogen, and it forms how many bonds? 3. The C? Is carbon. And how many bonds does carbon like to form? 4. So I just remembered that. Helped me when I was going through this HONK 1, 2, 3, 4 rule. Okay, this slide contains all the rules for writing Lewis structures. There's a lot of them. They're in your guided notes. You don't have to write anything here. They're all inside your guided notes, but I want to go through them before we try a practice problem. Okay? So rule number 1, we're going to add up all the valence. So add up all the valence. Please underline that. Add up all the valence in the whole molecule. So we know how to find valence electrons. We're going to add them up for the whole molecule. That's number 1. Rule number 2. Determine the central atom. Please underline central atom. This is the one that goes in the middle of the molecule. Okay, and I want you to underline a couple more things. Hydrogen is never the central atom. Hydrogen will never go in the middle. But carbon, if you have carbon in your molecule, it is always the central atom. So underline those two things. Carbon always goes in the middle, hydrogen never does. Okay, number 3. After you have determined the central atom, you're going to draw the central atom's electron dot structure. So if you have carbon, it's going to look like this. You're going to draw C with 4 dots around it because it has 4 valence electrons. Okay, then step 4, you're going to connect the remaining atoms to the central atom. So you're going to put other atoms here on the sides. But remember, I want you to underline this. Molecules prefer to be symmetrical. What does symmetrical mean? Yeah, it's like a mirror image. You want to make them look the same on both sides. Okay, so they like to be symmetrical. Number 5, remember the octet rule. So underline octet rule when deciding where the electrons go. How many do they want? 8. Except for hydrogen and helium, they want 2. Okay. Number 6, remember that covalent bonds are shared electron pairs and are represented by a single line. I want you to underline covalent bonds and single line. Okay? 1 line equals 2 dots. We'll go through that here in a second. Rule number 7. Unshared electron pairs, underline this, unshared electron pairs are called lone pairs. Please circle lone pairs. We're going to talk a lot about lone pairs coming up. Well, if they're unshared, it means they're not between 2 different atoms. They're not shared pair or covalent bonds. They're just unshared. They're by themselves. And we're going to keep them, and they're going to be 2 dots. We just call them lone pairs. Okay, rule number 8 is very important. To check your work, simply count the dots and the lines. And remember, a line equals 2 dots. All of the electrons that you did in number 1, so all of these valence electrons that you totaled up, should be accounted for when you finish. So number 8 goes back to number 1. You should kind of compare and make sure that you have accounted for all valence electrons in that molecule. Okay, I'm going to refer to these rules as we go through these practice problems. Okay? But before we go through a practice problem, I wanted to review electron dot structures. I know this is not in your guided notes, but if you guys would take a second and write them at the top of your page here or in the margin somewhere, can you write the electron dot structures for these elements? I'll help you through this one, okay? I hope that on your periodic table you have this labeled. 1 valence electron, 2 valence electrons. Group 3 has 3, 4, 5, 6, 7, and 8. In fact, this guy only has 2 though. Those are valence electrons. So if we're going to write the electron dot structure for carbon, which sits right here, how many, what should I do? You draw its symbol, and then you guys remember this? You put a dot at the top and then just kind of work yourself around clockwise and put 1 on each side. And since carbon has 4 valence electrons, it has 4 dots, right? Okay, I would like you guys to try the rest of them. Lithium is Li. It's right there. How many dots by it, guys? Just 1. Does it matter really where the dot goes? Doesn't really matter. Neon. Neon sits right here. How many dots? Yeah, it's got 8 dots. So 1, 2, 3, 4, 5, 6, 7, and 8. Does it already have an octet? Yeah, it's already obeying the octet rule. So, number 4, magnesium sits right here. Mg is its symbol. Guys, can I draw the dots here? Do electrons like to be by each other? No, so let's separate them. Could I draw it like that? Yeah. Could I also draw it like this, though? A dot up top and a dot down below? Would that mean the same thing? Yeah, it would. So it doesn't really matter. Oxygen is O, and oxygen sits right here. So how many valence? 6. So I'm going to draw 6. 1, 2, 3, 4, 5, and 6. Okay, so oxygen looks like that. And hydrogen. Hydrogen sits right here. It's got 1 valence, so H with 1 dot by it. Okay. So hopefully that's a quick review of electron dot structures. What we're going to do now is make molecules from this. And we're going to put them together. Let's try a practice problem, and hopefully this makes sense. Practice problem number 35. It says to draw the Lewis structure for the following molecule. CH4. Okay? So I'm going to review those rules. I know they're in your guided notes and you have them right there. But I'm going to review them. Rule number 1 was to do what? Count all the valence. How many valence from carbon? Isn't there 4? So put a 4 like right there. Just do exactly what I'm doing, and I will go through it. So carbon has 4 valence electrons. How many valence electrons does hydrogen have? 1. So I'm going to put 1 here. But how many atoms do I have of hydrogen?
4.
4. So we're going to times that by 4 and add these together. So in the whole molecule, how many valence do I have? 8. So I'm going to make note of that. 8 valence electrons. Okay. Rule number 2 says determine the central atom. Does hydrogen ever go in the middle? No. Does carbon go in the middle? Yes. If you have carbon, it's always going to be in the middle. So let's draw it first. Let's draw its dot structure. It's got 4 valence, so we're going to put an electron on each side going around clockwise. It looks like that. Now, rule number 4 says connect the remaining atoms. Well, we've got 4 hydrogens left. Can you predict where they're going to go? Hydrogen, if it comes here, how many electrons does it bring to share? 1. So you're going to draw its electron here to share, just like that. Where do you think the other 3 go? Well, just around it, right? And brings 1 electron to share each case. Okay, and so it looks like that. Now, rule number 5 says remember the octet rule. Guys, how many electrons does it feel like hydrogen has by it now? 2. Okay, hydrogen feels like, in each case, it feels like it has 2 electrons. How many does hydrogen want? To become like a noble gas here, it wants 2. So is it obeying the octet rule then? Yeah. Carbon, how many does it feel like it has? 1, 2, 3, 4, 5, 6, 7, 8. So is it obeying the octet rule? Yeah. Okay. So rule number 5 was done. Number 6. It says, remember that covalent bonds are shared electron pairs and are represented by a single line. Is this a covalent bond right here, guys? Are they sharing electrons between 2 different atoms? They are. And so we represent that with a line. So a chemist would actually draw this molecule. Its Lewis structure would look like this. Okay? And so that's how they would draw it. That's what I want to see you guys draw. Okay? I want you to make a little note here, though. If they're between 2 atoms, that's called a covalent bond. Okay? They're between 2 different atoms here. So it's a covalent bond. We don't have any unshared pairs or lone pairs, so that's it. Now, when you're done, I want you to do this. We should always, like on number 8, it says to check your work. How many electrons does a line represent? 2. So how many electrons do we have here? 2, 4, 6, 8. Do I have all 8 valence electrons accounted for? And the answer is yes. Are they all obeying the octet rule? Yeah. So there's my answer. That is the Lewis structure for CH4. Okay, let's go to another practice problem here, number 36. Practice problem number 36. Let's try it, okay? All right, so we've got this molecule here. It's NH3. This is a very famous molecule in chemistry. It's ammonia. So let's go through those steps again. Step number 1 was to count the valence. How many valence from nitrogen? Nitrogen's right here, so how many valence? Hopefully on your periodic table it says 5, because it does have 5 valence. Hydrogen has 1, but how many do I have? 3, so let's times that by 3. So what's 5 plus 3? Again, that's going to be 8 valence electrons. Okay, so rule number 2. Which one goes in the middle? Does hydrogen ever go in the middle? No. So we know that nitrogen's our central atom. We're going to write an N. And how many dots by it? 5. 1, 2, 3, 4, and 5. Okay. Now let's move on. Step 3, we just did the central atom. Step 4, connect the remaining ones. And remember, it likes to be symmetrical. So if I put a hydrogen here, and it brings 1 electron to share, where should I put the other one? Well, to make it symmetrical, I'm going to put it down here. But there's 3 of them, so I need to add another one down here, and that's what this compound will look like. Okay. Now let's go to the next rule. It says, remember the octet rule. Let's see if they're obeying the octet rule. How many valence electrons does it feel like hydrogen has? 2. How much does it want? 2. Remember, hydrogen wants to be like helium and have 2 valence electrons. How many does it feel like the nitrogen has? 1, 2, 3, 4, 5, 6, 7, and 8. So is it obeying the octet rule? Sure. Okay, let's go to the next step. Number 6. Remember that covalent bonds are shared electron pairs. Is this a shared electron pair? Is it shared between 2 different atoms? Yes. Is this one? Yes. Is this one? But what about this one up here? It's not shared between 2 different atoms, is it? What do we call these 2 dots? This is a lone pair. Please write that in your notes. That's called a lone pair. These guys that are shared are called covalent bonds. So a chemist, when he would draw the Lewis structure, would do it this way. So you've got your nitrogen. These shared pairs are lines. And for the lone pair, you just keep it as 2 dots. Okay? And that's our answer. Let's account for all the electrons like step 8 wants us to do. How many electrons does a line account for? 2. So we got 2, 4, 6, 7, 8. Do I have all 8? Sure. And before we finish this, I forgot on the last problem, but there's that HONK 1, 2, 3, 4 rule. How many bonds does nitrogen like to form? It likes to form 3. Does this nitrogen have 3 bonds on it? Yeah, 1, 2, 3. How many does hydrogen like to form? 1. Every hydrogen has 1 bond on it. And so that is how you would do NH3. Okay, let's go to practice problem number 37. It says to draw the Lewis structure for the following molecule. I would like you guys, if you're watching the video, please try this one first. So hit pause on your video, try it, and then once you have your answer, hit play and see if you got it right. Okay, let's see how you did. I'm just going to go through the steps real fast. So we've got carbon here. Carbon has 4 valence electrons. So carbon's right here. It's got 4. Hydrogen has 1 valence electron. but I've got 3 hydrogens, so I'm going to times that by 3. And chlorine sits right here, has 7 valence electrons. Okay, so if we add up all of these valence electrons, we've got 14 valence electrons in this molecule. So that's step number 1. Step number 2, we're going to decide which atom is our central atom. And remember that carbon, if we have carbon, always goes in the middle. So I'm going to start with carbon and draw its dot structure. It's got 4 valence, so I'm going to put 4 dots. 1, 2, 3, 4. Okay, now if you go to step 3, it says draw the central atom, which we just did. And number 4, connect the remaining atoms, but remember it likes to be symmetrical. So I've got 3 hydrogens. The hydrogens are pretty easy all the time. I'm going to put one here. Hydrogen brings 1 electron to share. So every time I draw a hydrogen, I'm bringing 1 electron to share. Okay, and then I've just got this one last atom. It's chlorine. Okay, so I'm going to put chlorine over here. And it's got 7 electrons. So 1, 2, 3, 4, 5, 6, and 7. And so that's how I did it. Now you might be asking, could you put the chlorine on top? Or could have I put this chlorine on the left or bottom? And the answer is yes. It's really arbitrary. It doesn't matter where you put the chlorine. So, okay, let's go to the next step. It says, remember the octet rule. Let's see if they're obeying the octet rule. Hydrogen wants 2. It's got 2. This hydrogen has 2. This hydrogen has 2 electrons. So the hydrogens are the carbon, 1, 2, 3, 4, 5, 6, 7, 8. It feels like it has 8 valence electrons, which is what it wants. This chlorine, 1, 2, 3, 4, 5, 6, 7, 8. So the chlorine feels like it's obeying the octet rule. Now, let's go to the next step. Number 6, it says, remember that covalent bonds are shared paired. So if they're between 2 atoms, I'm going to circle them. These are our covalent bonds. So when you finish your Lewis structure, a chemist would really draw it like this. The covalent bonds are lines. So if they're between 2 different atoms, it's a covalent bond and we draw a line. But I've still got these electrons around the chlorine. Okay, they're not between 2 atoms. So these ones are just called lone pairs. And so I've got 1, 2, 3 lone pairs around the chlorine. And so this will be my answer for this problem. But before we end, I wanted to go through and like number 8 says, let's check and make sure I've got all of the 14 valence electrons accounted for. So I've got, and remember a line is 2, so 2, 4, 6, 8, 9, 10, 11, 12, 13, 14. And so I've got all 14 accounted for, and all of them are obeying the octet rule. Now, also before I end, I want to emphasize the HONK 1, 2, 3, 4 rule. Hydrogen forms 1 covalent bond. Each one of these hydrogen has 1 covalent bond. We have a carbon. It should form 4 covalent bonds. 1, 2, 3, 4, and it does. And so the H could also stand for halogens, and chlorine is a halogen, and it forms 1 covalent bond. And so that's your answer. Hopefully that makes sense. Okay, let's go to practice problem number 38. Practice problem number 38 says to draw the Lewis structure for the following molecule. This is the most famous molecule in the world. So I want you to try this one on your own first. So if you're watching the video, please hit pause, try it, and see if you can get the Lewis structure for water on your own. Once you have your answer, hit play and see if you got it right. Okay, let's see how you did. First of all, I'm going to count the valence for the whole molecule. Hydrogen has 1 valence electron, sits right here, has 1 valence. But I've got 2 hydrogen atoms here, so I'm going to times that by 2. Okay, let's add that to the valence for oxygen. Oxygen's right here, and it's got 6 valence. So we got 2 plus 6 is equal to 8 valence electrons for this whole molecule. All right, step number 2, we're going to decide which one is our central atom. And remember that hydrogen never goes in the middle. It's never going to be the central atom. So let's go to oxygen and draw its dot structure. Okay, it's got 6 valence electrons, so let's draw 6 dots. 1, 2, 3, 4, 5, and 6. Okay. Now the next step says to fill in your outside atoms. Our outside ones are going to be the hydrogen, and so you can kind of predict where hydrogen's going to go. You can't put more than 2 electrons on one side, so it's got to go on the left and the bottom for me here. So I'm going to draw my hydrogen. It brings 1 electron to share, and this hydrogen brings 1 electron to share. Okay, and now let's go to the next step. It says if the electrons are between 2 atoms, so the shared pair, we need to draw them as a line because these are our covalent bonds. So we've got 2 of them there that are between 2 different atoms. So let's redraw it with lines this time. So we've got our oxygen, a line coming to the hydrogen, but we still have these electrons on the top and the right side, which are our lone pairs. Okay? And so I think this is the answer, but let's continue through the rules and go through it step by step and make sure. Okay, it says when you get down to step 8 to make sure that you've accounted for all the valence electrons in the molecule. Okay, so we've got 2, 4, 5, 6, 7, 8. Remember, a line counts as 2, so 2, 4, 5, 6, 7, 8. So yeah, I've got all 8 valence electrons. Now another thing you might want to check every time is to make sure they're obeying the octet rule. Hydrogen wants 2. Well, it's got 2 electrons there, and this hydrogen has 2 electrons. Remember, hydrogen just wants to be like helium and have 2. Oxygen wants to obey the octet rule, it has 8 electrons. So 2, 4, 5, 6, 7, 8. And so it feels like oxygen has 8, which is what it wants. Okay. Let's go over the HONK 1, 2, 3, 4 rule again. I've got hydrogen. Hydrogen has 1 valence, not valence, but 1 covalent bond. And so it does there, and this hydrogen has 1. Oxygen wants 2. And so this oxygen here has 2 bonds. And so we're following the HONK rule as well. All right, very good. That's the Lewis structure for water. Let's go to practice problem number 39. And I want to go through this one with you. There's a new trick to this one that I would like to go through and do this one with you. So let's start. Let's see, this carbon's right here, has 4 valence electrons. So I'm going to count up the valence electrons for this molecule. Hydrogen has 1 valence, sits right here, it's got 1 valence. But there's 2 hydrogens, so let's times it by 2. Okay, and we're adding in the valence electrons for oxygen, which has 6 valence electrons. Okay, so I got 4 plus 2, that's 6. Plus 6 more is 12 valence electrons in this molecule. I should have 12. Okay, step 2 says decide which atom here is going to be our central atom. And you'll notice from the rules that if you have carbon, that's going to be your central atom. So let's draw the dot structure for carbon. Has 4 valence, so I'm going to draw 4 dots. Okay. And now we need to decide where the outside atoms are going to go. And a lot of this is arbitrary, but you should always try to make it symmetrical. So let's see here. What I'm going to do is put a hydrogen on the left side, and remember it brings its 1 valence electron to share. And I'm going to put it on the right side to try and make it symmetrical. Okay, so I've got my hydrogens accounted for. I need an oxygen. It doesn't really matter whether you put it on top or bottom. I'm going to put mine on top, and it's got 6 valence electrons. So I'm going to draw 6 dots around it. 1, 2, 3, 4, 5, and 6. Okay, so you'll notice something new when you draw the Lewis structure for this molecule. You're going to notice these single electrons on the carbon on the bottom and on this oxygen on the left side. So let's try and determine what's happening here. Okay, if you move down in the rules, we want to make sure that they're all obeying the octet rule. Okay, and hydrogen wants 2, it has 2 here. This hydrogen wants 2, and it feels like it has 2. Carbon wants 8, but it feels like it has 1, 2, 3, 4, 5, 6, 7. So it's only got 7 valence electrons. So it's really not obeying the octet rule, which is a problem. This oxygen, let's count the electrons here. So 1, 2, 3, 4, 5, 6, 7. So our carbon and our oxygen are not obeying the octet rule. Here's the deal, and I want you to pay attention to this. When they're not obeying the octet rule and you have single electrons, what you can do is shift these electrons around so that they form another covalent bond here. So I'm going to move this single electron here in between, and I'm also going to move this one up, and it's also going to share between the carbon and the oxygen. So if I redraw this, it will look like this. So now I have 2 shared pairs between the carbon and the oxygen. So instead of 1 shared pair, I've got 2 now because I moved this other one and this one down. But I've still got these lone pairs on my oxygen up here. Okay? And so now let's recount and make sure they're obeying the octet rule. My hydrogens are good. They've got 2. The carbon, though, feels like it has 1, 2, 3, 4, 5, 6, 7, 8. The oxygen feels like it has 1, 2, 3, 4, 5, 6, 7, 8. And so now they're all obeying the octet rule. But now let's draw it so that our shared pairs are drawn as a line, which represents covalent bonds. So when I redraw it, it's going to look like this. And now I've got 2 shared pairs between the carbon and the oxygen. And that's something new. This right here is called a double bond. This between the hydrogen and the carbon is called a single bond. But now we've introduced a double bond. And that's okay. We can even have triple bonds if we need to have triple bonds. And so this is what I think the answer is for the Lewis structure. But let's make sure. Okay, let's count the electrons, and I should have 12 accounted for. Remember, a line counts for 2, so there's 2, 4, 6, 8, 9, 10, 11, 12. So I've got all 12 accounted for, and everyone's obeying the octet rule. So that is the answer for practice problem number 39. Okay, now that we've tried one with a double bond, I want you to try this one on your own, and I'm going to give you a little hint. It does have a double bond in this molecule. So if you're watching the video, please try it on your own. Hit pause right now and try it on your own. Okay, let's see how you did. Again, I'm going to go to the first step, which is to count the valence electrons in the molecule. Carbon sits right here, it has 4 valence electrons, but I have 2 carbons, so I'm going to times that by 2. Let's add in the valence from the hydrogen. Hydrogen sits right here, it has 1 valence, but I've got 4 hydrogen atoms. So I'm going to times that by 4. So if we add them up for the whole molecule, I've got 8 plus 4. That is 12 valence electrons. Step 2, we're going to decide which one of these atoms is going to go in the middle. And remember that carbon, if you have it, always goes in the middle. So I'm going to draw carbon and then draw its dot structure. It's got 4 valence, so 1, 2, 3, 4. Now I've got to decide how this molecule is going to be structured. Remember, it likes to be symmetrical. So I'm going to put another carbon atom to the side of it. Okay? And I'm going to put the 4 dots. It brings 4 dots. So 1, 2, 3, 4. Okay, so now I have my 2 carbons. Now I'm going to put in my outside, my other atoms here. I've got 4 hydrogens. Now if I'm going to make it symmetrical, I'm going to bring 1 here. And remember, it brings 1 electron. To make it symmetrical, I'm going to put one on the other side directly opposite. And then it's kind of arbitrary. If it doesn't matter where you put this one. So I'm going to put one on top here. And I'm also going to put one on top on this carbon. And remember there, it brings 1 electron to share. Okay, so as of right now, my molecule looks like this. So let's go through and see what we have here in terms of the octet rule. Hydrogen wants 2, and it feels like it has 2. This one does, and this one has 2, and this hydrogen has 2. So the hydrogens are good in terms of the octet rule. The carbon, though, let's check it. So we've got 1, 2, 3, 4, 5, 6, only 7. And this carbon has 7. So again, if it only has 7 valence electrons, we're going to look for these single electrons, and we're going to bring them in between and share them. So there'll be 2 pairs of shared electrons between the carbons. So let's redraw that. So what it's going to look like with 2 shared pairs will look like that. And then I've got my hydrogen on the left, on the top here, and on the top here, and on the right. Okay? So all I did was move these single electrons up and shared them again. And so now we have 2 shared pairs here. Okay, now let's go to the step that says if it's between 2 atoms, 2 different atoms, that's called a covalent bond, and we represent that with a line. And so I'm going to draw my finished product up here. So it's going to look like this. We have a carbon. It's got 2 shared pairs between the carbons, so that's 2 lines. So that's a double bond between the carbons. To the hydrogens, it's just 1 covalent bond, so 1 line. And so my finished product, at least I think this is right, we're going to check it, would look like this. Okay? And so now let's make sure that we've got accounted for all 12 valence electrons. Each line represents 2, so there's 2, 4, 6, 8, 10, 12. And so yes, I have all 12 valence electrons. Now let's make sure they're obeying the octet rule. Hydrogen wants 1 or 2 electrons, so each line, it's obeying the octet rule on each of these. Now the carbon wants 8, so there's 2, 4, 6, 8. This carbon feels like it has 8. Let's check this carbon. 2, 4, 6, 8. And so yeah, everyone's obeying the octet rule, and we've accounted for all valence electrons, and that's what would be the answer for practice problem number 40. Okay, good job. Let's go to practice problem 41. I want you guys to try this one on your own. If you're watching the video, please hit pause, try it first on your own and see what you get. Then once you have your answer, hit play and see if you got it right. Okay, let's see how you did with this problem here. So nitrogen, we're going to count the valence first. Nitrogen sits right here and it's got 5 valence electrons. So I've got 5 valence, but I've got 2 nitrogen atoms. So I'm going to times that by 2. Now we're going to add up all the valence for this molecule. So the hydrogen, which sits right here, has 1 valence. But if you look, I've got 2 hydrogen atoms. So I'm going to times that by 2. So we've got 10 plus 2, which is equal to 12 valence electrons. Okay? That's step 1. Step 2 is to decide which atom will be our central atom. Which one goes in the middle? Hydrogen, if you recall, never goes in the middle. So I'm going to put nitrogen in the middle. So I'm going to draw nitrogen's dot structure here. It's got 5 valence electrons, so 1, 2, 3, 4, and 5. Now when you're trying to complete the molecule, remember that it wants to be symmetrical and that hydrogen never goes in the middle. So I'm going to put my other nitrogen to the side. And again, it's got 5. So draw 5 dots around this one. 1, 2, 3, 4, and 5. Okay, so now I've just got these 2 hydrogens left to put on with this molecule. And remember, it wants to be symmetrical. So if I put one here, remember it brings 1 electron to share. I'm going to put the other one directly opposite so that it's symmetrical. And so it looks like this to this point. So now let's count and see if they obey the octet rule. This hydrogen feels like it has 2. This hydrogen feels like it has 2. And that's what hydrogen wants, is 2 valence electrons, so we're good there. But the nitrogen, 1, 2, 3, 4, 5, 6, 7. It wants to have 8. So remember, if you don't have enough, we look for electrons that we could share. And you notice that there's a single electron below each nitrogen here. If we move that up and share and create another shared pair between them, that will help the nitrogen obey the octet rule. So let's redraw it doing that. So we have hydrogen, the nitrogen, and now there's two shared pair between the nitrogens. Okay, and then we've got another hydrogen over here. And don't forget our lone pairs above the nitrogen. So these lone pairs here, we have to still draw them in. Okay, so that's what it will look like now. Let's see if they're obeying the octet rule. The hydrogens are, they've got 2 electrons, which is what they want. My nitrogen here has 1, 2, 3, 4, 5, 6, 7, 8. So it feels like it has 8, and it feels like it's obeying the octet rule. And so does this nitrogen. So now, we just got to remember that if it's a shared pair between 2 different atoms, we draw a covalent bond with a line. So let me draw that up here. So this Lewis structure will look like this. And remember, our lone pairs above the nitrogens will stay there. So now let's count the valence electrons and make sure that we have 12. We've got 2, 4, 6, 8, 9, 10, 11, 12. And so I've accounted for all 12, and each atom is obeying the octet rule. And so that is my answer. And I just wanted to go back to that HONK 1, 2, 3, 4 rule. Hydrogen should form 1 covalent bond, which it does. This hydrogen has 1, this hydrogen has 1. Nitrogen, though, should form 3. So if we look at our nitrogens, we've got 1, 2, 3 bonds. 1, 2, 3 for this bond, or for this nitrogen as well. And so we are obeying the HONK, the octet rule, and that's the correct Lewis structure for this molecule. Let's go to practice problem number 42. And I want you guys to try this one on your own, but I want to give you a hint. It's got 4 hydrogen, but they list it and they write the molecule this way to give you a kind of a hint in the structure of the molecule. So this carbon is going to have the 3 hydrogens on it, and it's going to have an oxygen. And this hydrogen will be connected to this oxygen. So there's a little hint, I hope. So try it on your own first, see what you get, and then press play and see if you got it right. Okay, let's see how you did. Again, I'm going to go through the steps. Let's count up the valence in the molecule. Carbon sits here, has 4 valence electrons. Okay, I'm going to add that to the rest of them. Hydrogen sits right here, has 1 valence. So that's 1 valence. But I have 3 hydrogens here, so we'll times it by 3. Let's add that to this oxygen, which sits right here, has 6 valence electrons. And let's add that to this 1 more hydrogen. Again, hydrogen has 1. So if we add this all up, we got 4 plus 3, which is 7. Plus 7 more is 14 valence electrons. Okay, let's decide which one goes in the middle. Carbon is always going to be our central atom. So let's draw its dot structure here. Carbon has 4 valence electrons. So I'm going to draw 4 dots around it. Okay, now let's fill in the outside atoms. I've got 3 hydrogen here. So it doesn't really matter where you draw them, but remember they bring 1 electron to share. So there's my 3 hydrogen. Now they wrote the formula for this molecule like this. The oxygen is connected to the carbon here. So I'm going to draw the oxygen here, and it's got 6 valence electrons. So let's draw 6 dots. 1, 2, 3, 4, 5, and 6. Okay. And now I've got the hydrogen, which is connected to the oxygen. So let's draw our hydrogen in there, and there's only 1 spot for this hydrogen to fit, and that's right there. Okay, and remember it brings 1 dot to share. Okay, now we're almost done. Let's make sure that everyone's obeying the octet rule. Hydrogen wants 2, and each hydrogen feels like it has 2 valence electrons. Carbon wants 8. It's got 1, 2, 3, 4, 5, 6, 7, 8. Oxygen wants 8. It's got 1, 2, 3, 4, 5, 6, 7, 8. So they're all obeying the octet rule. Now let's redraw it using lines for the covalent bonds. Remember, covalent bonds are shared electron pairs between 2 different atoms. So when we draw it, it'll look like this. The carbon is going to form a covalent bond with the hydrogen on top, on the left, on the bottom. On the right, it's going to be with oxygen, and then we've got another one coming down with the hydrogen there. Okay, now I've got lone pairs here on the oxygen. I've got 2 lone pairs. I can't forget to draw them in. They stay as dots. Remember, they're not being shared between another atom here. So they're called lone pairs, and they just remain as dots. So that's what I think the Lewis structure is for this molecule. But it's always a good idea to check. Okay, let's see if we have all 14 valence electrons accounted for. So we got 2, 4, 6, 8, 10, 11, 12, 13, 14. So I've accounted for all 14, and every atom is obeying the octet rule, so that's my answer. Whenever it has an OH on it, this is an alcohol group, and you'll see that as you go through further chemistry courses. This alcohol is called methanol because there's just 1 carbon. And so, anyway, you'll learn how to name alcohols in organic chemistry. All right, practice problem 43. This is the last practice problem for Lewis structures that I have. So I would like you to try this one on your own. Again, hit pause in your video, try it on your own and see if you can get it right. Okay, let's see how you did. Let's total up the valence electrons for this molecule. Carbon, which sits right here, has 4 valence electrons, so 4 valence, but you'll notice I have 2 carbon atoms, so let's times that by 2 and add that to the rest of the molecule. I've got hydrogen, so 1 valence electron, but I've got 2 hydrogen atoms, so I'm going to times that by 2 as well. So I've got 8 plus 2, which is 10 valence electrons to account for in this molecule. Okay, now we got to decide which one's going to be our central atom or which one's going to go in the middle. Carbon always goes in the middle. So I'm going to draw carbon with its dot structure here. 1, 2, 3, 4. Now to make it symmetrical, I'm going to put another carbon directly to the side of it, and it's got 4 valence electrons. So let's bring them in. 1, 2, 3, 4. And now I've got to put in my outside atoms. I've got 2 hydrogens. If I'm going to make it symmetrical, if I put one on the left side, and remember it's got 1 valence electron, I'd better put the other one, to make it symmetrical, I'm going to put it on the opposite side, the right side. So that's what it looks like so far. Okay, let's count and make sure that the atoms are obeying the octet rule. Hydrogen wants 2, and this hydrogen feels like it has 2, so it's obeying the octet rule. This hydrogen wants 2. So in terms of the octet rule, the hydrogens are okay. Now let's count for the carbons. So it's got 1, 2, 3, 4, 5, 6. Okay, not even close. It's got to get to 8. So what can we do? If we need more electrons to meet the octet rule, we got to share more. So I've got these single electrons here. I'm going to take this one and share them between the carbons. Okay, so if I redraw that now, it's going to look like this. So I've got my hydrogen, 2 dots, carbon, and between the carbons now I have 2 shared pairs. Okay, I've got another carbon and then a hydrogen on the right side. But I've got still 2 more electrons on the bottom of these carbons. Okay, so now let's see where we're at in terms of the octet rule. the hydrogens, of course, are good. They've got 2 each. So let's count the carbon. So the carbon has 1, 2, 3, 4, 5, 6, 7. So still not obeying the octet rule, even though we have 2 shared pairs between them. So what can we do? Well, if it's still not obeying the octet rule, let's share these electrons between the carbons and see what happens. Okay, so if I redraw that, I'm going to draw it up here. So I've got my hydrogen, carbon. Now carbon, let's see if I can draw a little clearer, has 3 shared pairs between them now. And then there's another hydrogen on the right side. So now let's count and see if it's obeying the octet rule. Nothing changed with my hydrogen. They still have 2, which is what they want. Now let's see how many electrons it feels like this carbon has. So 1, 2, 3, 4, 5, 6, 7, 8. So now it feels like this carbon is obeying the octet rule. Let's count for this carbon. 1, 2, 3, 4, 5, 6, 7, 8. And so everyone's obeying the octet rule now. But let's draw it like a chemist would, representing covalent bonds with a line. And so again, if there are shared pairs between 2 different atoms, they're going to be covalent bonds. So I'm going to have a hydrogen, and then I'm going to have a single line to the carbon, but I'm going to have 3 lines between the carbons, and then another single one here. Okay. And so because they're all shared between 2 different atoms, they're all covalent bonds, and so that's what it will look like. So this is the first time that we have seen a triple bond. And they exist. So hopefully you got that as your answer for that molecule. That is the Lewis structure. Let's make sure, though, account for all these 10 valence electrons. So each line counts for 2. So 2, 4, 6, 8, 10. And so I've accounted for all 10 valence electrons, and each atom in this molecule is obeying the octet rule. So, all right, good job. I've got one more slide, and then we'll finish this video. I've got some extra practice if needed. We might go through these in class, but I'm not going to go through them right now. So the one last slide that I wanted to talk about, let's see if we can get through these. Oh, I've actually got a couple of slides I would like to talk about. So this table is a good table. It represents bond length and compares that to the bond energy, the energy to create or to break that bond. So what I wanted to point out, single bonds, the length in terms of the other ones, single bonds are pretty long relative to a double bond. Notice how the length is greater with the single bond. But if you look at the energy required to break or to form these bonds, a single bond has the least energy. A double bond has more energy. And if we have a triple bond, let's see, do we have a triple bond over here? Yeah, a triple bond, even more energy. So triple bonds have the most energy and they're the shortest. Single bonds have the least energy, but they're the longest. So anyway, I wanted to point that out and make that correlation there. Okay, I wanted to finish this video with properties of covalent compounds because we've been talking about covalent compounds, which are 2 nonmetals. So if you look at the periodic table, this staircase here, we're talking about compounds or molecules that are made up of 2 nonmetals. So covalent molecules tend to be non-conductive, which means they don't conduct electricity all that well. They don't at all. They have low boiling points. So at the point at which a liquid becomes a gas is very low. Okay, low boiling points. They have low melting points as well. Covalent molecules tend to be very flammable. And so I wanted to contrast this to ionic compounds. ionic compounds were very conductive. They had high boiling points and high melting points. And they were not flammable in most cases. So anyway, I wanted to end the video there. Now that we know how to do Lewis structures, I want to give you some more practice. And I've got a worksheet in your student workbook. It's called Lewis structures. So I'd like you to go there in your student workbook and complete the Lewis structures worksheet now. And hopefully this video helped.